Welcome to Trinod chemistry classes. In this video, I am going to discuss about some important named reactions present in intermediate second year chemistry, that is organic chemistry. There are around 20 to 25 named reactions in intermediate second year chemistry. In this video, I am going to discuss about some of the named reactions, some of the important named reactions present in this intermediate second year organic chemistry topic. First one is Aldol condensation. Aldol condensation. What is Aldol condensation? First important named reaction is Aldol condensation. When aldehydes or ketones having alpha hydrogen, undergoes condensation reaction in the presence of mild bases. Mild bases such as barium hydroxide and forms beta hydroxy aldehydes or ketones. This reaction is known as Aldol condensation. Aldol condensation. What is an aldol condensation? When aldehydes and ketones having alpha hydrogen undergoes condensation reaction in the presence of mild bases and forms beta hydroxy aldehydes or ketones. This reaction we are calling it as the aldol condensation. Aldehydes or ketones having alpha hydrogen undergoes condensation reaction in the presence of mild bases such as barium hydroxide and forms beta hydroxy aldehydes or ketones. This reaction we are calling it as the aldol condensation. Before going to this aldol condensation, we need to know first what is an alpha hydrogen and then what is a condensation reaction. What is an alpha hydrogen and what is a condensation reaction? What is an alpha hydrogen? You see, in a carbon chain, suppose if a carbon chain is there, and in this carbon chain, if a functional group is there like this, some functional group is there here, like this, some functional group is there, then the carbon adjacent to this functional group, we are calling it as the alpha carbon. Then next carbon, we are calling it as the beta carbon. Next carbon, we are calling it as the gamma and the delta like this. Right? The carbon attached to the functional group is called alpha carbon. Adjacent to this alpha carbon is called beta carbon, gamma carbon and delta carbon and so on. Hydrogens attached to the alpha carbon. Are called alpha hydrogens. Hydrogens attached to the alpha carbon are called alpha hydrogens. So generally aldehydes and ketones participate in this aldol condensation. So which aldehydes will participate? Those aldehydes or ketones having alpha hydrogen will participate in this reaction. So this is the first one. Second one is, what is a condensation reaction? You see, condensation means combining two molecules, combining of two or more molecules by the removal of a smaller molecules, such as water, ethanol, and so on. See, if two or more molecules are combining, adding by the removal of smaller molecules such as water, those reactions we are calling them as condensation reactions. We are calling them as condensation reactions. Condensation reactions means the reactions in which two or more molecules will combine by the removal of smaller molecules such as water. Those reactions we are calling them as condensation reactions. Now, aldol condensation is the aldehydes or ketones having alpha hydrogen. Aldehydes or ketones having alpha hydrogen undergoes condensation reaction in the presence of base to form beta hydroxy aldehydes or ketones. This reaction we are calling it as the aldol condensation. Here, in objective point of view, the question may ask like this. They may give 4 aldehydes or ketones. Which aldehyde will participate in aldol condensation? Which aldehydes will participate? Aldehydes having alpha hydrogen. Aldehydes or ketones having alpha hydrogen. Having alpha hydrogen participate in this aldol condensation reaction. Now, let me take ethanol. You see, this is the functional group. CHO is the functional group, and this is the corresponding alpha carbon. There are 3 hydrogens attached to it, this alpha carbon. That's why there is an alpha hydrogen. Now, the aldehydes having this alpha hydrogen undergoes condensation in the presence of base to form beta hydroxy aldehydes or ketones. Beta hydroxy aldehydes or ketones. Now, you see, this is the functional group. This is the alpha carbon. This is the beta carbon. There is a OH group on this beta carbon. That's why it is called beta hydroxy aldehydes of ketones. Now, its IUPAC name is 1, 2, 3, 4. 3 hydroxy butanol. 3 hydroxy butanol, its IUPAC name is. Let me take another example. CH3CO CH3. This is called acetone or propanone. Propanone is the IUPAC name. Commercial name is the acetone. You see here, in the presence of base, what is happening is CH3CO CH2 COCH. Now, its name is 1, 2, 3, 4, 5. You see, its name is pentanone, 2 pentanone, but there is a 4 hydroxy, 4 methyl, 4 hydroxy, 4 methyl pentanone, 4 hydroxy, 4 methyl pent-2-O, pentanone. Its name is 4 hydroxy, 4 methyl pentanone. Aldehydes are ketones having alpha hydrogen. Here also, this is alpha carbon. There are 2 alpha carbons in this. Then there are 3 hydrogens on each alpha carbon. The 2 aldehydes of ketones having alpha hydrogen undergoes condensation reaction in the presence of base, forms beta hydroxy aldehydes or ketones. This reaction, we are calling it as the aldol condensation. Aldol condensation. Let me explain mechanism. How this reaction happens. Mechanism. You see, the first step is formation of carbanion. We know that carbanion is the negatively carbon containing negative charge is called carbanion. Negatively charged carbon is called carbanion. In the first step, what happens is one aldehyde molecule loses its alpha hydrogen and forms carbanion like this. You see, this OH minus attacks the H. You see what happens is here CH3 like this. H. What happens? This OH minus attacks this hydrogen and like this. It loses as a bond. In the first step, what happens is formation of it. First step involves the formation of carbanion. Formation of carbanion. In second step, what happens is attack of carbanion on the second aldehyde or ketone. Second aldehyde. You see what happens is CH3, C double bond OH, CH2 minus CH. Now what happens is this carbanion attacks the carbonyl carbon of second aldehyde or ketone. Carbonyl carbon of second aldehyde or ketone. Then immediately this bond polarizes like this. Then what happens is CH3, C, O minus, and here H, CH2, CH2. In next step, what is happening is here it undergoes hydrolysis. CH3, CH, CH2, CH, which on heating forms CH. OH and H will be removed, and here we will get aldehydes, beta hydroxy aldehydes or ketones. So this mechanism involves the formation of carbanion. This is the first important point in objective point of view. Second step is the attack of carbanion on the carbonyl carbon of second aldehyde molecule. Attack of carbanion on the second carbonyl carbon of second aldehyde molecule. So this is about aldol condensation. Now let me take one more example to understand the mechanism. You see, let me take acetone, propane. You see, what is the product I have written? You see, in the presence of base, what is happening? CH3, OH, CH3, CH2, C double bond O, CH. Right? Now, what is the mechanism? Mechanism is first step is formation of carbanion by the removal of alpha hydrogen. OH minus CH2, C double bond O, CH. Then you see this is alpha carbon, this is also alpha carbon. There are 3 hydrogens on this side carbon. There are 3 hydrogens. That's why one of the hydrogen will be removed. Then in second step, whatever carbanion formed in the first step attacks the second aldehyde, second ketone molecule. CH3, CO, CH3 plus CH2 minus C double bond with CH. Now what happens? It attacks like this. Then what happens? Like this. Then CH3, O minus CH3. CH2, C double bond over CH. Right? Or let me one more time, let me write this. You see what happens is here CH3, C, O minus CH3, CH2, C double bond over CH. Then next step occurs hydrolysis. Then CH3, OH, CH3, CH2, C double bond CH. So if further heating, which forms heats. Right? So this is regarding aldol condensation. See what is aldol condensation? Aldol condensation is the condensation reaction between 2 aldehydes or ketones having alpha hydrogen in the presence of base to form beta hydroxy aldehydes or ketones. This reaction we are calling it as the aldol condensation. So this is one of the important named reaction in organic chemistry. One of the important named reaction in organic chemistry. Here, few basic things needed to be remembered in objective point of view is, you see, which aldehydes will participate, which aldehydes or ketones will participate. The aldehydes or ketones having alpha hydrogen only will participate in this reaction. Second one is, they form beta hydroxy aldehydes or ketones. Beta hydroxy aldehydes or ketones. Then next step is, this is a condensation reaction. This is a condensation reaction, Aldol condensation, right? Then next step is, here the mechanism involves the, which intermediate involves the formation of carbanion intermediate. Carbanion intermediate. This carbanion attacks the, this carbanion attacks the carbonyl carbon of, carbonyl carbon of second aldehyde molecule. Second aldehyde or ketone molecule. Second aldehyde or ketone. See, few basic things needed to be remembered are, one is, those aldehydes having alpha hydrogen only will participate in this aldol condensation. If there is no aldol or alpha hydrogen, there is no aldol condensation. Then they form beta hydroxy aldehydes or ketones. It is an example for the condensation reaction. And the mechanism involves the formation of carbanion intermediate. Negatively charged carbon, we are calling it as the carbanion. And in this carbanion attacks the carbonyl carbon of second aldehyde molecule. Second aldehyde molecule. So this is regarding aldol condensation. Aldol condensation. Now, next step is, next reaction is, next important named reaction is crossed aldol condensation. Crossed aldol condensation. What is a crossed aldol condensation? You see, in aldol condensation, two aldehydes or two ketones, same aldehydes or same ketones participates, then this is called aldol condensation. You see, in our previous example, we have seen CH3, CH2. It forms CH3. You see, both are acetaldehydes or both are acetones only. Same aldehydes which participate, that is called aldol condensation. If two different aldehydes are two different ketones are an aldehyde or and a ketone. An aldehyde and a ketone undergoes two different aldehydes or two different ketones, or an aldehyde and a ketone undergoes condensation in the presence of base, forms beta hydroxy aldehydes or ketones. Beta hydroxy aldehydes or ketones. This reaction we are calling it as the crossed aldol condensation. This reaction we are calling it as the crossed aldol condensation. You see, the basic difference between aldol and crossed aldol is, in aldol, both the aldehydes are same. Two aldehyde molecules are participating, or two ketones are participating. Both are same aldehydes. If two different aldehydes or two different ketones are an aldehyde and ketone having alpha hydrogen, here condition is same, having alpha hydrogen undergoes condensation in the presence of base, forms beta hydroxy aldehydes or ketones. This reaction we are calling it as the crossed aldol condensation. We are calling it as the crossed aldol condensation. Crossed aldol condensation. You see, let me take one more example. CH3, CH2 plus. You see, here I am taking two different aldehydes. One is ethanol or acetaldehyde. Then second one is propane or propanol. Here, this aldehyde is also having alpha hydrogen and the second aldehyde is also having alpha hydrogen. Here we will get, in aldol condensation we are getting only one product, but here we will get four different products. Four different products. You see, CH, OH, CH2, CH2. This is one product. Then second product is CH3, CH2, OH. This is the second product. Then third product is CH3, CHOH, CH2, CH2. Then fourth product is CH3, CH2, OH. This is the fourth. You see, why four products are formed? 1, 2, 3, 4 different products are formed as two aldehydes are having two aldehydes are having alpha hydrogen. Why four products are formed? You see, let me this molecule form M1, this M2. This is a molecule. M1 may form, M1 forms carbanium. M1 forms carbanium and attacks M2. Right? This is the first product. Right? So this is the second product. Right? This is the product 2. Product 2. Similarly, M1 forms carbanium and attacks M1 itself. Attacks M1 itself. This is the product 3. This is the product 3. Similarly, M2 forms carbanium. M2 forms carbanium and attacks M1. This is the product 1. Similarly, M2 forms carbanium, attacks M2 itself. Then the product 4 will be formed. So in crossed aldol condensation, there are 4 products are formed. You see, the first product is, you see, CH3, CH2. This ethanol forms carbanium, CH2 minus CH4, which attacks the second aldehyde, CH2, C double bond OH, CH2 minus CH. Then what happens? CH3, CH2, CO minus H, CH2, CH. In next step on hydrolysis, this forms CH3, CH2, COH, CH, CH2, CH. This is the first step, first compound is formed. Right? You see what happens? Ethanol forms carbanium and attacks the propanol. This is the first product. Now, second product is propanol forms the carbanium. Propanol forms the carbanium. So what is the alpha hydrogen? You see, this is the alpha hydrogen. This is the alpha hydrogen. This is the alpha hydrogen. Propanol forms carbanium, attacks the ethanol. Attacks the ethanol. Then what happens? CH3, COH, H, CH, CH3, CH. So this is the second product. Now, third product is what? Ethanol forms carbanium, attacks the same ethanol like aldol condensation. Propanol forms carbanium, attacks the propanol itself. That is the fourth product. So this is regarding crossed aldol condensation. You see, aldol condensation or crossed aldol condensation. Which aldehydes will participate? Those aldehydes will have alpha hydrogen only will participate. Alpha hydrogen only will participate. You see, in aldol, both the aldehydes are same ketones. In crossed aldol, two different aldehydes or two different ketones or an aldehyde and a ketone will participate in condensation reaction. You see, in aldol condensation, only one product is forming. In crossed aldol, there are 4 products are forming if both the aldehydes having alpha hydrogen. If only one aldehyde is having alpha hydrogen and another is not having alpha hydrogen, in that case only 2 products will be formed. 2 products will be formed. This is regarding 2 important named reactions in second year organic chemistry. Thank you for watching Trinath chemistry classes. Please subscribe my channel, like the video. Thank you.